All right, so we're going to take a look at a handful of different examples of these inscribed angles. So part A, if arc DG is equal to 46 degrees, so let's find arc DG. Here it is right here. If that is equal to 46 degrees, what are the measure of angle E and angle F? So angle E is over here. If I follow the sides of angle E out, do you see how arc DG is the intercepted arc for that angle? Angle E is an inscribed angle because the vertex is on the circle. So when you have an inscribed angle, the measure of angle E is equal to half of its intercepted arc, which is DG. So we know that DG is 46 degrees. So half of 46 is 23. So angle E is equal to 23 degrees. All right, how about angle F? So if we find angle F, it's an inscribed angle. It's on the vertex is on the circle. If we follow the sides of the angle out, what we notice is it is intercepting the same arc. So the measure of angle F is equal to half of its intercepted arc, which is also arc DG. Well, we know that DG is 46 degrees, so half of 46 is 23 degrees. So angle F is equal to 23 degrees. Well, isn't that interesting? So we now know that angle E is congruent to angle F because they have the same measure. So that leads us to our first little theorem, intercepting the same arc. If two inscribed angles intercept the same arc, then they are congruent. So if we look at this picture, we can see angle S, this inscribed angle, vertex is on the circle. If we follow the angle out, it's intercepting arc RU. Angle T, if we follow that out, it is intercepting arc RU. So angle S and angle T have the same intercepted arc. RU. That's the intercepted arc that's the same. Therefore, angle S is congruent to angle T. So if you ever notice that two inscribed angles have the same intercepted arc, we may conclude that the angles are congruent. All right, part B. Given circle Q, find the measure of angle RST. So angle S is an inscribed angle. If we follow the sides of the angle out, the arc it is intercepting is arc RT. So we know that angle RST, that's the angle at S, the inscribed angle is equal to half of its intercepted arc, so half of arc RT. And if we look at arc RT, we can see that it is half of the circle. From R to T, those are the endpoints of that diameter, and that is a 180 degree arc. So half of 180 degrees is 90 degrees. So angle RST is equal to 90 degrees, which makes that a right angle. All right, so the theorem we get from that. So inscribed angle, I'm going to change that to in a semicircle. If an angle is inscribed in a semicircle, then it is a right angle. And just to show you another picture of what that looks like, whoa, not that one. So here's a circle, here's the center. I'll go ahead and draw on the diameter. If your inscribed angle, so I'm going to draw an angle with the vertex on the center. if that inscribed angle has endpoints that go to the end of that diameter, so it's in a semicircle, your inscribed angle will be a right angle every single time. All right, part C. If arc ABC is 184 degrees and arc ABC is 242 degrees, what are the measures of the angles of the quadrilateral ABCD? Okay, so angle A is equal to half of its intercepted arc. So if we take angle A and we follow it out, it's going to be half of arc BCD. Because see how angle A goes out here? It's half of BCD. And they told us that arc BCD is 242 degrees. So angle A is half of 242 degrees, which makes angle A equal to 121 degrees. All right, let's take a look at angle B. Angle B is an inscribed angle of the vertexes on the circle. If we follow the sides out, it's equal to half of the intercepted arc, which is going to go around this way, arc ADC. So angle B is equal to half of arc ADC. And we'll come back to that one once we have a little bit more information to help us figure out what arc ADC is. Next, we can move on to angle C. Angle C, the vertex is on the circle. It's equal to half of its intercepted arc. So if we follow this out, that's going to be half of arc DAB. So arc DAB is right here, and we know that arc BCD is 242 degrees. They told us that. So that's just kind of the rest of the circle. So if we do 360 minus the 242, that's going to get us arc DAB. So arc DAB, if we do that subtraction, is equal to 176. And then half of 176 is 88 degrees. So angle C is 88 degrees. All right, so I want to go back up to, because we're going to kind of do that same idea. Arc ADC, so angle B is equal to half of arc ADC. So let's find arc ADC. ADC right here, angle B is equal to half of that. If we look at arc ABC, we were given arc ABC as 184. So the other arc that we need is 360 minus 184, which is 176. So arc ADC is 176. So angle B is equal to half of 176. Half of 176 is 88 degrees. So angle B is 88 degrees. All right, last we have angle D. So let me go ahead and do a little erasing. If we look at our picture, angle D is an inscribed angle. It's equal to half of arc ABC. So angle D is equal to half of arc ABC. That's the intercepted arc. And, oh, they told us arc ABC is 184. So it's half of 184, which is 92 degrees. So angle D is equal to 92. All right, you guys, I just caught a mistake. So I hope you're using pencil. For angle C, arc DAB right here, I said was 176. It's not, never was. It's actually 118 degrees. So let's go ahead and rewrite that 118 degrees. And then half of 118 degrees is going to be, angle C is 59 degrees. All right, so one thing that we can notice right here, angles A and C are opposite angles in the quadrilateral, and 121 plus 59 degrees add up to 180. Angles B and D are opposite angles in the quadrilateral, and 88 and 92 add up to 180 degrees. So if you have an inscribed quadrilateral, so 1, 2, 3, 4 sided figure inscribed, so inside a circle with all those inscribed angles, if a quadrilateral is inscribed in a circle, then opposite angles are supplementary. They will add up to 180 degrees. All right. Part D, angle RST is 164 degrees. So let's find, not angle, I meant to say arc. Arc RST. So RST, this arc is 164 degrees. Now, if we follow the end of that arc to find the sides, see how this is getting me to the inscribed angle? So this angle at V, we're going to be able to figure out that angle. Angle RVT, remember the angle RVT is equal to half of the arc RST. So here's an inscribed angle at V. We follow the sides out. This angle is equal to half of its intercepted arc. So because we know the arc, we can figure out half of that 164 degrees, and we are getting that angle to be 182 degrees. So angle RVT is 182. All right, last one for this really long example. Thanks for sticking with it. I'm going to get rid of some of that so we can use the same picture. So if the measuring angle SPU is 79 degrees, so SPU, that's this angle right here. It's an inscribed angle with the vertex P on the circle. That is 79 degrees. What is the measure of arc STU? So if I find arc S, I have to go through T to U. That is the intercepted arc from that inscribed angle. So remember, the inscribed angle SPU is equal to half of the intercepted arc STU. So this time, what's different is we actually know the angle measure. We know the inscribed angle is 79 degrees. That's equal to half of the arc. And the question is, what is the arc? Well, 79 is equal to half of something, right? So it's got to be bigger than 79. We can solve for that by just multiplying both sides by 2. And now we get arc STU is equal to 7 times 79, which is 158 degrees. So the intercepted angle is equal to half of the arc. The arc is also twice as big as the intercepted angle. So there's kind of two ways to look at that relationship.